Hello, Keith Rucker here at VintageMachinery.org. Guys, today we are working on our electrical panel for our new control panel for our Monarch 10EE lathe that we're replacing the DC drive components in there. I've already built the panel here, I got all the components attached to it, and now is the time that we're going to start wiring this thing up. So I've been working with a gentleman, John from Minnesota, who's an electrical engineer. He has been helping me with this project, providing tremendous input, and has really designed all of this stuff that we're working on. And I have some wiring diagrams that he has sent me, and today is the day we're going to start trying to get all this stuff wired up so that we can start playing around and testing things out over there and seeing if we can get this whole thing to work like it's supposed to. I say, and seeing like we're going to make it work. So we're going to get started on that today with getting some wiring here. So let's get in here and get at it. All right, so I've got a bunch of wiring diagrams here, and people are already asking, will I share these? And at some point down the road, possibly yes. Right now, this whole thing is still a work in progress, and there's probably going to be changes to this. We're still got some things I know that we've got to add in at a later date. We've got to do some trial and error experimenting with some stuff before we know exactly how we're going to do a couple of things. So what I'm doing, it's not really 100% ready to go right now. So just keep that in mind that we will be making some changes and what have you. So I'm really not ready to share any of this stuff at this point in time. What I am ready to do is start wiring it up so that we can start that testing process. We're going to be using some of the controls on the lathe, so not everything's going to be on this board. We will be going over and at some point in time wiring this into the lathe controls and hooking them into everything so that we can control it from the lathe, because that's ultimately how we're going to be doing it. So without further ado, let's get in here and figure out where we want to start from. I've got in my plans here a bunch of stuff is off the machine or off the board. So we like our disconnect switch is over on the lathe. We've got a transformer, control transformer, it's on the lathe. Our drum switch to do the forward and reverse is on the lathe. The on-off power button is on the lathe. So some of this stuff, you know, we're not going to be wiring right now. I'm really just wiring the board up. So on this diagram, pretty much everything from here up is kind of off the lathe. We're going to start kind of down here below. And I'm just going to pick a wire and go with it. We're going to start piecing this thing all together. As I connect a wire, I'm going to mark it off on the plan so that I know it's done and I can kind of follow where I'm at. So let's get in here and do it. Well, we got to start somewhere, and I think what I'm going to do is I'm just going to pick a wire and kind of start on one side of this and start working across. So wire 30, this is basically a common that's going to be going around to a bunch of my different motor starters, my relays on the back side, and it's going to kind of daisy chain between them. So I've already kind of cut me a piece of wire here. We're going to start there. Now, one thing that I've got is John really encouraged me to get a set of this Paladin Tools PA1113. It's a wire stripper. You just put it in there and it just pulls them back real easy. I've used various kinds of wire strippers over the years. Some of them I like better than others. For smaller wires, these look like they're going to do a really good job. So anyway, I kind of like them. Now, another thing I'm going to do is I'm going to be numbering all these wires. And I have, let me go over here and grab it and show you. It's a label printer that will go onto some heat shrink tubing that we can put on these wires and keep everything very well labeled. I want to be able to make sure that I can go back and double check my stuff and see exactly what wire we got off of our plan. So let's get that thing going. So what we're going to be printing the labels with, or printing the heat shrink tubing with, is this Rhino 5200. This is just a label maker made by Dymo. It's a Rhino 5200, but this particular model will allow you to print onto heat shrink tubing. So I've got some heat shrink tubing in different sizes. These smaller wires I'm using 1/4 inch tubing, and all I'm going to do is just put the wire number on it. So I've got the 30 in there, which is the wire number, and we're just going to go ahead and print that, and it should send it right out the back here. Let's see, there's a little cutter there. I just put that piece of, or that thing of tubing in there, so it's printed out a little bit longer than it needed on that first one. But what we're going to do now is, this is again tubing. We will open this up, slide it over the wire, and heat shrink it in place. All right, we'll just feed our wire up in there like such, and I'll grab my heat shrink gun and we'll heat shrink that right in place. It's just a heat gun, kind of looks like a blow dryer, but it gets a lot hotter. And we'll just put that on there, and the heat from it, as it warms up, we'll just shrink that right onto that wire. We'll have a nice label to tell us what's going on. So we've got a nice label on that wire. We're going to feed it in down here into that terminal and tighten it up. Hopefully this is going to make life a lot easier, being able to keep track of my wires, see what's going where. That wire on there, I think what I'm going to do is go ahead and put it in place, and then I will heat shrink this where I can see what wire that is pretty easily. All right, one down. This is going to take a lot of time. So from this, we're going to daisy chain it down to our control relays, which are on the other side. So I'm basically going to need to just come in and go through this opening to the other side. So let me go ahead and get a piece of wire coming in here. This one's just going to daisy chain right off of that same terminal. And we'll heat shrink that label in place. And this is going to go around to control relay number 1, terminal 14, which is this one back here. And we're just going to, again, we're going to be actually daisy chaining all these together. It's going to be a common one that goes between all of them. So let me go ahead and get my wire cut. Now, this is going to be daisy chaining between all these, so I need to just cut me a bunch of wires here, and we'll put them all in place. These will just go from one to the other. All right, we have our common wire, comes in from the other side, comes into the first control relay, daisy chains all the way up to this one, and then this one comes over here. So that looks good. We've got another one that's going to come out of this later on and go to another place, but I'm not ready to put it in yet, so we just went ahead and tightened that up. So let me figure out what we want to wire up next. Well, I almost messed up, but I caught myself before I did. The wiring diagram said to go to terminal 14 on these relays, and that's where I've got them all at now, which also is the A2 terminal, basically your neutral for your input. What confused me is there's two lines of numbers on these. There's a bottom line and there's a top line, and there's a 14 here, and I don't know why, but terminal 5 over here is also terminal 14, because 14, 24, 34, 44. Now, why they put two 14s on there, I'll never know, but we got it straightened out, and we are ready for our next one. So the next terminals on there is going to be wire 32 off of this wiring block here. So I need to get those going where they need to go. So they're going to be going also to, to the control relays, and maybe a couple other places too. Let me see. Let me figure it out. We'll get some wires headed there. Well, guys, this is tedious, time-consuming, and honestly kind of boring to watch anyway. I've spent a couple of hours putting all these wires in here, getting them properly numbered, and we're not even through yet. But I kind of worked through a section here on my drawing, and but we still got a little ways to go, a good bit of ways to go, but we are making progress here. Making nice progress, in fact. So just thought I'd give you a quick update. I am going to come in here with some wire ties and wire tie these so that they will look neater, but I'm kind of waiting to get everything in there first so that it doesn't I don't have to go back and redo things later, basically. But it's coming along good. We'll bring you back in a little bit and show you some more progress. Well, guys, I think we have the panel all wired up, and I saved you guys the boredom of watching me do this. I'm going to just start out by saying that this was a long job. It took me probably about 12 hours to wire this thing up, and mostly did just sitting over at my bench, taking my time. And I will say right up front that that was way longer than it should have taken. And the big reason why it took me so long is I was having difficulty at first reading the schematics. I wasn't really used to it. I made a few mistakes, had to go back in as I was figuring things out, had to rewire some things a couple of times to get them right. But I've got everything. It's been checked and double checked and triple checked. Everything should be exactly right now. And I feel confident that when I go to do the next one that it'll go much, much faster, because I really learned a lot along the way. This type of wiring is not something I've done a lot of, really any of, throughout my life. I've done a lot of electrical work, like wiring a building and even, control wiring in a machine. But when you get into this kind of stuff with relays and motor starters and everything that's going on in these drives, it's kind of a new skill set for me that I've had to learn. But I'm happy with how it looks. Everything looks real good. I tried real hard to keep it neat. This is the front side of the panel, and you turn around, that's the back side of the panel. So again, relays mostly on this side. We got a timer and some terminal blocks. This is mostly relays that are turning different things on and off. And on the front, again, we have the two drives, a couple of motor starters, some fuse blocks and relays. There is a potentiometer in here to adjust some of the field current stuff, I think. I may not be right, coming out of one of these. Now, one thing I wanted to kind of follow up on, because looking at the comments in the original video, I think there's a lot of people that really don't understand why we have to have the two drives in here. And I did not do a great job of explaining it. I'm still learning this as I go. And I'm really starting to kind of wrap my mind around this. But the DC motor that drives this Monarch 10EE lathe is a little bit different than your average DC motor that I think most people are familiar with. Most people are familiar with a DC motor. It has two wires that goes to it. You can hook, positive and negative up to it, and it runs. You can vary the speed by changing the current that goes through there. The motor that is in my lathe, instead of having two wires that comes out of it, has 6 wires. Yeah, get enough fingers in there. 6 wires that come into it. And also, your typical DC motor that most people are going to run into, either going to run at either 90 volts or 180 volts. The DC motor, the armature on the DC motor that I'm running is at 230 volts. So not a lot of off-the-shelf speed controllers that can do everything that needs to be done over on this machine. So really, you can think of it as a 4-quadrant or 4-wire system. There's actually 2 extras that I'll talk about in a minute. In fact, the other motor for the older lathe, it only has 4 wires. But you basically got the current that's going to the armature, this your variable speed, but there's also what's called your field that goes to it. And the field current that goes to there is actually changing the magnetic field in the motor. Now, most DC motors have a permanent magnet in them. That's the reason they only have 2 wires. With this one, we actually can change the magnetic field inside that motor as it's going, and that allows us to do some special things when you're running at higher speeds and lower speeds. And particularly when you start overspeeding the lathe, which this lathe is designed to run over speed, and it has to do with you can weaken the fields, and that will help with the heat that's generated in there. Now on this lathe, there's actually an additional 2 wires that go through it, and this is for a series field, which gives the motor extra torque by increasing the field strength when there's a heavy load. So again, it's a little bit more complicated than your typical thing, and we're having to actually control at least 4 of those different things. And to do that, to make it even more complicated, the armature current needs to be at 230 volts. The field current needs to be at 115 volts. So that's the reason we have 2 different controllers that are doing this. They do make some controllers out there that are 4-quadrant motors, but they're the ones that at least we were able to find are off the shelf are not designed to run the different voltages and be able to run in the voltage range that we need for this lathe, which is why we're having to use 2 separate controllers. So hopefully that helps explain it, and I probably still did a poor job, but that's kind of where we're at. So what's next? Next, I need to get over to the lathe, and we need to start wiring up some of the controls on the lathe itself. All that stuff will connect to this board, but we're going to go ahead and get all that wired up on the lathe, and then just have the wires that go over there. So let's get over here and see if we can start on that. So first off, what all have we got to get done over here? So real quickly explain what controls we want to use on the lathe to control that board with and power it and what have you. So first off, we've got a power disconnect down here. This is just a fuse disconnect. It's already wired up coming into it. We're just going to use that existing wire going into it, but that's going to go through some fuses in there for fuse protection, and then coming out of that we'll basically have our 220 volt power system that comes in here. So L1, L2, line 1, line 2, and the ground coming in from the power supply here in the shop. From that, it's going to come up to this area here. This is where we used to have a motor starter that kind of powered the lathe on. Now all that stuff is over on the board that we did. So that's no longer in here, but we are going to put a terminal block in here to allow us to connect wires, just to kind of make things a little bit easier so we can kind of follow what's going on. So we'll have the L1, L2 come into this terminal block. There will be L1, L2 that goes from the terminal block to the control board to provide power. And then there's actually going to be some fused power coming back from the board that's going to go down to the transformer, which will convert that 220 volts to 110 volts alternating current, and that will be for our control circuits that we'll use. So we'll have the transformer wires coming out of there, then coming back out at the other voltages that'll go back through the control block again. Other things that we'll have on here is there is the main power button for this. This is the actual button that goes on the other side of the lathe. There's a start and stop, and all this does is turn the power on and off. This will be controlling a motor starter and a relay or what have you over in the power board, but we got to have the controls coming into, we're wired into this transfer block here, and then that will wire into the machine. We'll also have a drum switch on the front that is this switch here. It's got 3 positions: forward, reverse, and off. So you go one way is forward, middle is off, backwards is forward. So that is in here. There's 4 wires coming out of that. That'll go into this, and again, it will then go to the board over there. So we've got several different things here that have all got to get kind of wired up properly. Eventually, there will be a potentiometer in here to do the variable speed control, but we're not quite ready to do that yet. Right now, I'm actually going to have 2 potentiometers, one for the armature and one for the field voltage that we can control separately. Eventually, once we kind of do some testing and work some things out, we're going to have a single potentiometer that will control both of those through an electronics board that we're going to be designing and putting in here. I say we, it's John up in Minnesota that's helping me with this. I'm not going to take credit for that. But anyway, let's get in here and start getting this wired in. I'm not going to show you the boredom of actually pulling wires, but I did want to kind of explain what all we're going to be doing. And with these terminal blocks here, again, that's going to get everything wired into this, and then we can get the wires over to the board. Now, in the final version, the wires are going to actually go snake down through the lathe and go to it, but for testing purposes, I'm going to leave the board out over here on the bench, so we'll have some wires that go over to that, but I can just tie in here, and then when it comes time to do the final version, we can pull the wires through the lathe and wire them in, which is why I want to put the terminal block here to be able to wire stuff in later on. All right, let's get these wires pulled. Step one here, we've got, again, power comes into the power cord, goes to the fuse block down here. This is the main fuses for the whole system. Disconnect, where we can turn things on and off. And coming out of the bottom, we have line 1, line 2. That's my 2 hot wires for 220 volt single phase power. Also have the ground coming in from the wall, grounded to the box, and then that also goes back up to the machine. We come up here, and my ground block on the bottom, we're again grounded to the machine, and we also have line 1 and line 2 and our ground block coming into our distribution blocks. I need to tie together these 2 grounds down here so we have plenty of connectors, but we'll get there. But power is to the distribution block now. Obviously it's not plugged in, but we have it there. I think next we're going to get our transformer, our control transformer wired in, and we'll send the wires down to that and get that all hooked up. So let me work on that. Well, I got the control transformer wired up over here, going down to it and back up. And I did some quick tests, and I just fed it the power. I put some loops in here just to test it out with the meter. And lo and behold, I got a problem with this transformer. I thought that this transformer was fine. I know that we smoked it a little bit previously. I had wrung it out and everything. It checked out, and it appeared to have been working once we changed the voltage back down before we ripped everything out. But half of the bottom end of this thing isn't putting any voltage out. So I'm guessing it shorted out and just didn't catch it. So I'm going to have to change transformers. I thought I had another one that I could put on here that was this type. I do have another one, but it's not the right transformer. It goes from 240 volts to 24 volts. I need one that goes from 240 to 110. So anyway, a little setback there, but no big deal. I'm going to continue wiring up this other stuff, and I'll see if I can find me another transformer. I've got a transformer that just mounts inside of a box that would work, but I would have to find an enclosure to put it in, or either mount it inside the lathe. So I'm going to ponder on that. We'll come up with a game plan and deal with the control transformer, but I can continue wiring this other stuff in the meantime. Up next, I have the drum switch that's going to be doing the forward and reverse. So this goes up in, and it's going to catch inside there, about like this. There's a pin on this end, and there's a handle on the front. And when you move it, right now it's in neutral. When you move it, it's going to flip this thing back and forth. If you look, there's a jumper between those two, and that's going reverse. It'll go to wires 35, 36, connect them. When you go forward, 37, 38 connects. There is this one here, when it's in the off position, it actually connects those wires. We're not using those in this setup. So, those are there if we needed them, but we're not really using them. So the way this works is I've already got my other ends labeled to match. And there's a little chase weight in here for the wires to go down into this opening that we've got. There we go. That's going to go up in the up position with the wires coming toward me. And it's engaged, and I got 4 screws in this cover that will get put back on. There we go. We have our forward reverse wires in there. I'm going to get the meter out and just double check them for continuity between those 2 pairs when the switch is in different places. just to confirm things, but I'll do that off camera. But there you go. All we got left now is the on-off 3-button wires, or 3-wire button, push-button switch. So we need to get that wired up from the front. So guys, I have finished wiring up the control buttons here. This is going to be the main power for the whole lathe. When you push the button, it turns the power on. When you push the stop button, it turns the power off. Pretty simple circuit here. We got 2 switches. The top switch is a normally closed switch. The bottom one is a normally, this is a normally open switch, which means that the circuit is not closed, that there's not power going through the circuit. This one is a normally closed switch, so that there is normally voltage going through here. The way this works is you have power that comes in on this wire 34. It comes to this terminal. Whenever we push this button in, it shorts out across these terminals. The power goes through here, down through this bottom switch. It goes through here because this is normally closed. This goes to the coil. It energizes the coil. And as soon as the coil is energized, it basically is sending the power that was coming on this wire in on 33. So once we release that switch, the power's in here. This time, the motor starter is engaged. The coil is on in the motor starter, and it's going to stay on until the power drops. Now to turn it off, we push this button. Again, this button does normally have a closed circuit in here, so this circuit is going to have power going through it. Whenever we push the bottom button, it opens that circuit. The circuit collapses, no power's going through here. So now again, we got power coming up here, but until we push this start button again, it's not going to energize the system. Pretty basic control button, basically 3 wires going to it. This one is always hot. This one is only hot when the coil is energized, and this is just basically to complete your circuit. So let's go get this installed and put it all together. We're over on the front of the lathe. This is where this mounts. There is a piece of conduit up in here in the top that will feed back to the back side. So we're just going to push these wires through. I have them numbered so that I know which one is which. Once we get them through, we can get all that sorted out. So we'll just feed that through. So that looks nice and clean. I got all my wires going to my different things. Everything looks good. One thing that we're going to have to change, though, as we mentioned before, the transformer down there is bad. So I'm actually going to take this transformer off. We're going to mount it in a different place. I'm going to have to rewire some of this, but let me get that going. I think what we're going to do is we're going to go down this piece of conduit. There's an electrical box inside, and I'm going to run the wires over into a cast iron cavity that looks like a compartment where some stuff like this could have potentially have been mounted. We're going to mount that control transformer in there, and probably go ahead and bring the wires that will go from this to the lathe through that same set of wires if we can get it all to work out. So let me continue on. I think we got it. The controls all wired up again. So the old transformer, just took it off. It's no longer in here. You can see the new control transformer is mounted up in this cavity. This is a sealed off cavity in the lathe. I believe it was actually made for electronics. There's actually 4 bosses in the cast iron back there for something to mount to. There were no holes drilled in it, but the feet on that transformer fit those bosses nearly perfectly. It's almost like that transformer was designed to go in here, which that transformer was not ever in this lathe. But regardless, I drilled and tapped some holes in the cast iron, and we mounted the transformer on there. I did not drill all the way through because that actually goes into a coolant tank behind that. So anyway, no problems there, but we got that mounted in there. It's all in there. It's all wired back up now. I ran a piece of flexible conduit from this port here over into that cavity, so we don't have any loose wires really floating around except for right there around the transformer. You can't see it, but that conduit goes all the way up to the transformer. I did come in here and I just put some jumpers from my hot lines coming in, the L1, L2, over to the T1, T2 that go to the transformer, and powered it up and came over here with my meter and checked everything out. And sure enough, everything is working like it should now. So we have a control transformer. It's been checked out. Everything is good there. And we've got power coming in, transformer on, off, or the forward, reverse, off switch up here wired in, as well as the on-off push button stations all wired into these terminals. And there will basically be wires from these terminals going to the control panel. I've got to figure out exactly how we're going to do that. There's some more conduits paths in here that we can take it down to the tray and get it hooked up, but that's coming down the road. Well, guys, I think that is going to be a wrap for this episode. We still got a lot of wiring to do to this machine, but we've really got accomplished what I set out to do. So first off, the panel back here is all wired up. It's ready to connect. I've got terminal boards on here where we can bring the wires from the machine to the motors. Everything like that will connect right into that. We've got most of the control wiring here. So again, we'll have wires coming from this terminal over to the terminals on the board. The only thing that I've really still got left to do is there is a reversing motor starter that's going to get mounted over here in the side of the lathe, and that's going to be for reversing the DC motor. I've still got to get that figured out, mounted, connected, everything like that, and get it wired in. And as well, it's going to have wires going over to the panel. For testing purposes, like I've mentioned before, we're just going to wire it right up over here on the bench, because there's going to probably be a lot of things we're going to be playing around with and having to do testing on. Instead of me having to get down on the floor, we're just going to work off of the bench here. Once we get everything finalized and worked out, we'll mount the control board down on the ground, and then or in the bottom of the lathe, and reconnect all those wires. But making good progress. This wiring is slow and tedious. It's not fast at all, but we're getting it knocked out just a little bit at a time. I've been coming out in the evenings after work and working out here for an hour or two at a time and just slowly knocking it out. And again, very happy where we're at. So with that, guys, that's going to be a wrap on this video. As always, thanks so much for watching. Please do subscribe to the channel if you haven't already. Thumbs up and comments, greatly appreciated as always. Leave those comments down below. Really, really appreciate those. And hit that bell icon to get notifications when new videos are posted. And with that, guys, we'll catch you on the next video. Again, thanks for watching.